Hey guys, and welcome to your very first video. This is Unit 1, Lesson 1, but before we get started, you're going to need the notes for today. So as you can see from the screen, we are on my website. This is where you'll find the notes you need for today's lesson. So under Class Info, go to Honors Geometry, and it is August 4th. So you're going to be looking for Unit 1, Lesson 1 notes. Now, when you click on this, it will download a PDF file that has all of my notes. It's like a guided note, so all you're going to do is just fill in as you follow me along. So that's what you need to do first and foremost, is make sure you have those printed. Okay, pause the video here because I'll begin the notes shortly. Okay, so now that you have your notes, let's go ahead and get started, okay? Today's very first lesson is on measuring and constructing segments. Remember, segments are just a portion of a line. They stop on each end, okay? So what tools do you need to have? Now, what you need to have out in front of you, as you can see from the pictures, is your compass, which you should have purchased for your school supplies, as well as a straight edge, which something like a ruler or the end of a binder will work fine. If you don't already have those in front of you, go ahead and pause that. Make sure you have it in front of you now, okay? Alright, so the very first thing we need to talk about is what is a construction, okay? And as you can see from the definition, it's a geometric drawing that uses only a compass and a straight edge. Now when I say a straight edge, it actually means not a ruler. Because a ruler, I could just measure this line segment here, AB. I could just measure that if I wanted to and copy it somewhere. Well, you know, back in the day, they didn't have rulers or a standard unit of measure, so they had to use just, you know, a straight twig or something that they could use, and we call this a straight edge, okay? So as you'll see from your notes, on your guided notes, which you should have in front of you, that I have given you step-by-step directions, okay? Now, the first thing that you need to do is we need to create a line somewhere else on the page. So I'm going to get my line tool out, and I'm just going to draw it. Now notice I'm going to make this longer than what I already have. Oops, I just threw that kind of far away, didn't I? Alright, so I need to make it longer, because what I'm going to do is I'm going to take this line and I'm going to chop it down to the length of AB. So what you're going to do is we're going to take this compass and we're going to open it up to the length of AB. Now the pointy end on one and the pencil end on the other. So go ahead and do that on yours. Now you're going to take your compass and you're going to move the pointy end right there on top of the end of your line segment that you made. Now what we're going to do is we're going to draw an arc right here. What that did was that measured the length of AB on top of the new line segment. So I can put my ruler away and I can see that, and let's go ahead and label these points. This will be point C. And this will be point D, so that we can see that line segment CD is the same length as AB, but it's in a different location, okay? So how can we verify that these two segments are in fact congruent? Well, if you have a ruler, you can go ahead and measure them, okay? So I would say a ruler to measure. We have a backup. We're going to use that technology to our advantage, okay? Alright, so why at the very bottom, why does this construction result in the same line segment length as line AB? Okay, I'm going to extend my page here. Notice that when we use a compass, okay, we opened up the width to exactly that of AB, and because we didn't change it, CD has to be the same. Basically what we're doing is we're ensuring that the radii of two circles is the same. So what we need to write here is that because circles, I made two circles and they both have the same radii, therefore they are congruent, okay? So let's go ahead and move on to the next construction. First off, how do you construct a circle with a compass? It's actually not that bad. Okay, all we're going to do is we're going to pick any point on this page. Doesn't matter where you put it. Okay, let's just call this, and then we'll say C for center. Okay, put your point on your center and open it to whatever you want. Okay, make it tiny, big, or kind of in the middle. Okay, And what you're going to do is you're going to hold your compass and make sure that the width does not change the whole way around. And just draw a circle. That's really all that is. So why is that important? Because if I were to say move this compass, notice I have not changed it at all. I have not changed the width. If I were to move it to say here at point A and then draw again, oh, my circle kind of fell off there a little bit, but what you can see, and I'll move it all up so that you can see this, is that both the circles, circle A and circle C, are in fact the same. I can actually take this circle and put it directly on top of the other one, and you'd never know the difference because it is the same circle, because the radii is the same. I didn't change the compass setting. Alright, so what does that mean for us in the math world? Well, the first thing I want to do is I want to see if you can handle creating a segment and a circle with a certain radius. So I want you to pause here and try these two problems. Alright, so for problem number 1, you need to create a line segment that is longer than KJ. I made it pretty big, but you know, you can make it as big as you need to. It's better to be too long than to be too short. So what I'm going to do is I'm going to take my compass and I'm going to open it up to the length of KJ. So let's get that taken care of. Let's see. Beautiful, right there. So this right now is set to the width of KJ. I'm going to put my point right there and I'm going to draw an arc right here. That means that from here to here is a new segment with the same length of KJ, and I'll name it AB. So if you're really wanting to show me, you can actually erase the rest of the line segment, but I'd still like to see this arc because it shows me that you didn't just use the ruler. Okay? Now to make a circle with the radius of KL, just put a spot anywhere for your center, and we're going to take our compass and move it to KL. Alright, and make sure that you're as close as you can. There you go. Now, put the point on the center and draw. There you go. Alright, now, this is actually very important. As you can see, it's called the segment addition postulate, okay? What that means is if you take a look here, that if I were to add the length of AB to the length of BC, that it would give me the length of the total segment AC. That makes sense, right? So let's say you're walking from one place to another. Let's say this was 4 miles. And then you wanted to walk another 2 miles somewhere else. Okay, that means that the total distance that you walked would be 6 miles. Easy, right? Alright, so let's put it into an example. First off, AB is 4 units long. Okay? And then BC is 9.3 units long. Okay, so what would be the total AC? All you would have to do is add 4 plus 9.3 and you get 13.3. Done. That is the length of AC. Alright, so let's go to our next example. This example says AC is 14 and BC is 11.4. Automatically, I know something is different. It says AC is 14. So A all the way to C is 14. They gave me the big piece this time. So this piece, BC, is 11.4. And I'm asked to find the length of AB. So instead of adding this time, I'm going to take the big piece, subtract what I know, 11.4, and in order to find AB, I get 2.6. Alright, so I want to talk about this problem because it has a variable in it. And a lot of times when we see variables, we get really confused and we want to give up, okay? But don't give up, I promise. This is the same way we did the previous problems, okay? Take a look at this piece, RS, and look at this piece, ST. Together, they make up the whole line segment RT. So together, RS and ST make up the whole segment 4X. Now, just by solving by order of operations and moving the x's to one side, we can solve. Pause the video, give it a shot. Alright, so as you can see, you should have gotten 17.5. If you did not, take a look at my work, see what you did incorrectly. Oh, and hey, here's your fun little tidbit for today. I have actually met Ed Sheeran. This is me and my sister over the summer, getting to see Ed Sheeran at a private concert sponsored by Q100. And my friends like to call me a lucky duck when it comes to winning things on the radio station. I figure you gotta ask a lot, and eventually someone will give you something. So, as you can see, I've met Ed Sheeran, so maybe tomorrow I might throw a pop quiz on the board and say, what famous celebrity did your teacher meet this summer? Alright, so back to the math. Alright, taking a look at this picture. It is a line segment AB. Notice these little tick marks right here and here. That means that line segment AM and MB are the same length. That's what those mean. Okay? So we know that AM is equal in length, so equal, to MB because of the little tick marks there. Now I know you're like, what's the fancy word for that? Well, I don't really know it, to be honest, but that's what we're going to call it, okay? So therefore, M is actually halfway between A and B, and we call that the midpoint. Might sound familiar from coordinate algebra, okay? And what does a midpoint do? It cuts line segments like AB in half, and we call that bisect, okay? So you should know these words, midpoint and bisect. Very important, okay? Alright, let's move on to our next construction. We are constructing a segment bisector. Okay, remember we just learned the word bisect means to cut in half. And segment is this line you see in front of you. So we're going to cut this line in half by just using a compass and a ruler. I know it sounds like a magic trick, but I promise it's not. Alright, so first things first, we're going to take our compass and put it on one of the points. I'll put it on A, just because A is the first letter of the alphabet, sure. Now, we are going to make an arc with this compass. Here's the thing though. I want you to go more than halfway. There's a reason for that, and I'll explain it in a minute. So make sure your compass is open to more than half of the length of your segment. Alright, go ahead and make an arc. Whoops. That's a big arc, but that's what I need. Okay, now here's what we're going to do. Do not change the width of your compass. Do you hear me? Don't change it. What I want you to do is I want you to move your compass without changing the width. Notice the width has still stayed the same. That's very important here. And do the same arc from your other point, point B. Okay? Now we can put our compass away. We don't need it anymore. What you see here is the intersection of the two circles, the two arcs that we made. Okay? And we need to connect these two intersection points to make a bisection. So I'm going to grab my line tool again. Let's see, there it is. And connect these two intersection points. What that does is it bisects line AB, so this point has to be M, my midpoint. So, the reflection question, how can you use a ruler to check that you did this correctly? Well, what you would do is measure AM and MB, and they should be the same length because a bisector cuts it into two equal pieces. Alright, last thing we have for today. Okay, another way to find a segment bisector. Let's say you've got this line on your paper. Well, what I want you to do is you have it right in front of you. Go ahead and fold your paper so that point A and point B sit right on top of each other. Fold it and make a crease right down that paper. Okay? Open it back up and your crease should be the bisector that we just made. Take a look at the four angles. What do you notice? They are all 90 degrees. Alright? And then how would you use the folding paper to make four segments of equal length? You would fold and fold again. Now that's all we have time for today, so I will see you tomorrow.